This video is about representing proportional relationships and how we can use tables, graphs, and equations to represent those proportional situations. Now, it's going to be a rather lengthy video, but I'm going to really dive into proportionality a little bit so that we can understand what that truly means. And if we can understand that, this makes things so much easier to be able to define those relationships. So first, let's talk about fractions. And what we know about fractions is this, is that if we take a fraction such as 1/2, and I multiply them by fractions of 1, 3 over 3, 4 over 4, and in this instance, I'm going to use 4 over 4, that would turn 1/2 into 4/8. And what we know is that it doesn't matter whether it's 1/2, 4/8, 3/6, 12/24. 1/2 is 1/2 all the time. It is constant. It is a constant fraction. It does not change if it stands alone. So using this idea of constants, it's going to help us to look at the definition of a proportional relationship. The definition states it is a relationship between two quantities where the ratio between them is constant. So let's talk about those words that are kind of in color here. The word ratio means we've got a fraction. When we're talking about a fraction that shows two quantities, two different quantities, we're not talking about a number, we're talking about units. So miles per gallon or feet per second, things like that. They're two different quantities, but the relationship between them is constant. So those two quantities that are a ratio, there's our rate. And that rate will be a constant rate. Now, I'm going to tell you that it does not need to be a unit rate, but there are times when we do need to find that unit rate, but not all the time. So just keep that in the back of your mind. So let's continue talking about this a little bit and know that all things that are proportional have a constant rate of change. Now, this is the key thing here, because what we know about this is that it will lead us into understanding that this is all called the constant of proportionality, this constant rate of change. So when we're talking about this constant rate of change, that's the constant of proportionality. And in math, we use the letter K to show this constant. Now, remember before we said that this rate or this ratio is a fraction. So this fraction looks like this, where we have the dependent variable y in the numerator and the independent variable x in the denominator. Now, I know this seems contrary to a lot of people's thinking. We always go in order of that alphabet, x, y, z, and we instinctively want to put x in the numerator. But the numerator is kind of driving this. It's depending on something. So because y depends on x, we start, because that's how it says, y depends on x, the y has to go first. The y has to go into the numerator. So let's take a moment so we can understand dependency and independent, because if we can understand that, then we should be able to move forward a little bit. So when we talk about dependent and independent variables, we have two groups of friends, dependent groups of friends and independent groups of friends. For example, when we talk about dependent groups of friends, these are people that when you say, hey, I want to go to the movies, and they'll, oh, I'll go too. And you're like, well, I want to go see this movie. Oh, I'll go see that movie with you. They're always dependent on what you're going to do. That's what we call dependency. Independent, if you think of your independent friends, if you say, hey, I want to go to the movies, and they're like, well, I want to go to the park. They're not really into what you're doing. They're going to do their own thing. That's why you see this little child here with all these different colors. That person's going to do their own thing, and if somebody comes with them, great. If not, they're okay with that. They don't depend on something else. So when we think about this in terms of the constant of proportionality, that dependent variable is our y, because it depends on something. It depends on our x. So we're going to take a look at this a little bit more in depth by looking at tables and seeing if we can see if this constant of proportionality exists. So let's take a look at this first one. And in this first table, we have the independent variable, which is x, stating 2, 4, 6, and 8. And the dependent variable, which is y, with 10, 20, 30, and 40. Now, what's important to notice or know about the constant of proportionality is this, is that we're going to look at finding out what this k is, and what we're looking for is what number would we multiply x by? Is there a number, k, that we could multiply times x to get us to y? And it's always to multiply. So let's take a look at these numbers and figure out if there is. 2 times what gives us 10? Well, we're thinking it's 5, right? So 2 times 5 is 10, and it works. 4 times 5 is 20, and it works. 6 times 5 is 30. That one works. And 8 times 5 is 40. So since multiplying by 5 works all the way through, we have a constant of proportionality that is 5. So yes, this is a proportional relationship. It shows a constant of proportionality, which is multiplying by 5 every single time. So let's take a look at another table and see, is there a constant of proportionality that exists here? This time, we're looking at the independent variable being 1, 2, 3, and 4, and the dependent variable y being 60, 120, 180, and 230. So if we take a look from 1 to 60, we would say that multiplying by 60 would 1 times 60 would give us 60. That works. 2 times 60 is 120. It works there. 3 times 60 is 180. It works there. And 4 times 60 is 240. So it does not work here. So no, this is not a proportional relationship because the constant of proportionality does not exist. Remember, constant has to be there all the time. And that's how we know something is proportional or not. Let's take a look at one more example. Again, when we're looking at the independent variable x being 8, 16, 24, and 32, and the dependent variable y being 2, 4, 6, and 8. Now, the other two examples, we saw what number we were multiplying the x by. It was making the dependent variable larger. In this case, that dependent variable is getting smaller. So what are we multiplying 8 by to get to 2? And I know a lot of people are thinking right away that, hey, we're dividing by 4. But remember, we're talking about ratios and fractions. We don't ever divide by a fraction. We multiply by the reciprocal. So we can say that we are multiplying by 1/4. And we want to know, is that the constant of proportionality that will exist every single time? So 8 times 1/4, or 8 divided by 4 equals 2. So we know that works there. 16 times 1/4 is 4. 24 times 1/4 is 6. And 32 times 1/4 is 8. So this does exist. We know that that constant of proportionality is 1/4 because it works all the time and it is constant. So this is how we know by looking at a table and knowing, is something proportional or not. So now let's take a look at all the different ways that we can show a proportional relationship. Now, I'm going to use my friend here, the whale, and the whale's going to help us to look at it in 4 different ways. Now, we did look at a table. We're going to introduce those other 3 ways right now. So here we have it in words, and I'm going to say that a whale can eat an average of 2 tons of plankton every day. Now, we have in our mind then what's really happening here, and from that, we can build our table that we were just talking about. So if I have a table that talks about days and plankton, we know that if no days go by, no whale exists, no plankton gets eaten. If after 1 day, we'll have 2 tons of plankton, after 2 days, 4 tons of plankton, after 3 days, 6 tons of plankton, and after 4 days, we'll have 8 tons of plankton. Well, what's happening here? What is going on that we are transforming from going from days to plankton, or going from the independent variable to the dependent variable? We can see that we're multiplying the days by 2. And what we're doing by multiplying the days by 2, can we write a rate for this? And we got to remember, when we're going to write our rate, our dependent variable is going to be in the numerator and our independent variable is going to be in the denominator, because that's going to give us our constant of proportionality. And when we're looking at this particular problem, we're talking about plankton divided by days. So we can say that we have 2 tons of plankton, I'll put plankton, divided by 1 day. So, and we know that 2 divided by 1 is equal to 2. So we do have a rate. We have a rate of 2. So we're going to call that our constant of proportionality right here and call that 2. Now from this, we can write an equation. This equation will help anyone, if we started there, put in any number of days, 100 days, 200 days, 450 days, to find out how much plankton this whale has eaten after so many days. So we know that the dependent variable depends. So y depends on, that's what that x is telling us. Y depends on what is happening to the x. And we said this constant of proportionality, we're multiplying every independent variable by 2. Well, there's our equation, y equals 2x. So if I wanted to know what was going to happen on the 350th day, all I have to do then is put 350 into that x, multiply it by 2, and I would know that 700 tons of plankton would have been eaten by that whale after 350 days. So this is how we write this equation, and we can see that it starts out with the dependent variable first, dependent, let me write that out, equals this constant of proportionality, right? And then we're going to multiply it times the independent variable. This is how we're going to set up our equations whenever we need to do that. So this should hopefully help people to understand that part. So now we've seen 3 types. We've seen it in words. Remember, we said it's going to be in different ways, right? We've seen words, we've seen a table, and we've seen an equation. So now we're going to see the last thing, which is probably the most typical, is seeing it on a graph. So here I have a graph all ready to go, and we see that we have labels. We have days on the x-axis and plankton on the y-axis. Again, our independent and dependent variables. So all we need to do is look over at our table and look at these points and put them on our graph. So 0 days, 0 plankton. So that's going to go right here in the corner. Then after 1 day, we're going to have 2 tons of plankton. 2 days, 4 tons of plankton. 3 days, 6 tons of plankton. And 4 days, 8 tons of plankton. Now, before I continue, I do want to talk about something. It's one of those things that I just want to take the opportunity to do it. So let me get my little magic pen here and see if I can make this get big so I can show you something. We tend to have a lot of people not know how to number a graph. So here it's going to pop up on our screen here. I hope you guys can see this. But what I'm showing here is that you can see that number 1, see how it's on the line? It's not in between the box. It actually is counting the line. So if I wanted to count the days, this is a half a day, this is a full day, this is a day and a half, this is 2 days. And you see the numbers are right on that line. And the same thing here. This is 1 ton of plankton, 2 tons of plankton, 3 tons of plankton. Now I can skip lines, and as long as everything is equidistant, because that's important, that equidistance, I can't say 1, then say 4 is the next one, and things like that. Every part of measurement has to be equal. So this is something to think about when you're building your graphs. You need to have the right units on the right axes. Remember, here's that x, that independent variable. We want to make sure that we have what's independent as that unit. We want to make sure that our units, as we write them on the axes, are actually on the line, so that what happens then is that it allows us to create a straight line. So let me grab a line here for a moment, and we'll put it in a pretty color. I'll make it blue. Okay, and we're going to draw a line here, and we're going to connect our dots. So we see a couple of things going on, right? Hopefully we get better here. Get it on there. Perfect. There we go. And why is this arrow? Why does it always have to have an arrow? Well, it has to have an arrow on the end because this is going on. Remember we talked about before that 350th days? I'm not going to show all the days, but this is going to keep on continuing on as this grows. Now, there's going to be some unique things about talking about proportional relationships, and we'll get to that in a second. But we see, we talked about words, a table, an equation, and a graph. And these are our 4 ways to show a proportional relationship. But there's other ideas and concepts out there that also show a constant of proportionality, such as the amount of money earned per hour. We know that the amount of money depends on how many hours, right? The hours are the x, the amount of money is the y. We also know that if a factory had to produce a certain number of bicycles every day, we know that the number of bicycles produced, that would be our y, and how many in the days would be our x. Here we have the number of days a car is rented in relationship to the cost. So the cost is what depends on how many days we're going to rent this car. So one depends on the other. And you see the relationship. Does it always list the dependent variable first or the independent variable first? No, it doesn't. So you really need to understand what depends on what. And here are the amount of time a hiker hikes and the distance traveled. So if I have a hiker who's going to go for 4 hours, well, then we get some distance. So this distance here is going to depend on how much time that hiker hikes. So those are just some things to think about. And what do all of these have in common? All these ideas have something in common. And it's a variety. It's about 1, 2, 3, 4 different ideas. So let me go through all of them. They're all going to show up on your screen, but I'm going to go through them one at a time. Okay. And again, I'm going to use my little magic pen to help us focus in on what I want to talk about. So let me get a big circle here. See if I can do it. Now, there it is. So let's see if I can make it a little bigger. So our first thing is that, let me get it over here. They're all graphed in the first quadrant because these are things that occur in the real world. Okay. We know that amounts of money is positive. We know days are positive. We know production is positive. These things are all positive relationships. So in a 4-quadrant graph, we're only going to see the first quadrant. Okay. What's also interesting is that they all start at the origin. So when we're looking at a graph, that graph is always going to start at 0, 0. Because in the real world, if nothing happened yet, then you can't have anything depend on it. Something has to happen before that dependent variable depends on something. Okay? Like I said, the outcome depends on something else. And the last thing is the rates are constant. There is a pattern in the data. We want to see that pattern. So what we're going to do is we're going to look at 3 examples. Like I said, these are a little long. I'm going to try and get through these examples, and we're going to take a different way of looking at things. We started the whale story with the words. Now I'm going to show you 3 different examples where we're going to start in different place. Either we're going to start with the table, we're going to start with the graph, or we're going to start with the equation, and we're going to build out from there. So this one, we're starting with the table, and the table is telling us that we have a number of students and we have a number of adults. Our number of students is 12, 36, 60, and 84, and our number of adults is 1, 3, 5, and 7. We know that y, our dependent variable, depends on what's going on here. And we're going to write a story because sometimes that's the easiest thing to start with. So let's think about something here. I've got one here, and I'm sure we can think of more. But let's say for every 12 students going on a field trip, there needs to be 1 adult chaperone. So if there are 24 students, we would need 2 adults. If there are 36 students, we need 3 adults, so on and so forth. We can see through this because what's happening is, in order to get from 12 to 1, right, what are we doing? We are multiplying by 1/12. Can we agree with that? 12 times 1/12 gets us 1. 36 times 1/12 gets us 3. 60 divided by 1/12 gets us 5. And 84 divided by 1/12 gets us 7. So if our constant, I'm going to pull this over here to the equation, if our constant of proportionality equals 1/12, we can write that equation. Y depends on the constant of proportionality multiplied by that x, that independent variable. So here's our equation that we're looking at. Now we want to put it on the graph. So remember, we're going to label our x-axis as the number of students. We're going to put our number of adults on the y-axis. We're going to add some numbers in here so that we are equidistant. And now we're going to plot some points. We know that we have 0, 0. Okay, we have, if there are 12 students, there's 1 adult. We have 36, so 36 and 3, so that'll put us in here. I didn't go to, I put 48, but we need to get to 64, so we're going to go another 12, which would put us here 60 and 5. Let me see. Let me come across here on 5, go across to 60. Okay, and then we're going to get our line like we were just talking about a moment ago, and we're going to build our line out. And it goes on forever because there could be more students coming on this field trip. And we can see in between that if I had so many students, how many more I would need, things like that. So now let's take a look this time. This time I've got a graph. And what this graph is telling me is that I have amount of money earned is my dependent variable, and the number of days worked is my independent variable. So let's build the table while we're looking at this, and we can put some numbers in. So the number of days worked, it looks like we've got 1, 2, 3, and 4. So let me add those numbers in here, 1, 2, 3, and 4. The amount of money earned, I could see after 1 day, I have $150. After 2 days, there's $300. After 3 days, $450. And after 4 days, $600. So we can see that there's something going on. Let's write those words. What could be happening? So here's my story that matches this, that Shelley earns $150 a day at her new job. Well, hopefully everybody can see from this what that constant of proportionality is. What are we multiplying the number of days by to get the amount of money earned? What are we multiplying the x by to get y? Well, hopefully everybody sees that that constant of proportionality is 150. So what we're going to say then is y is dependent on that constant of proportionality times that independent variable. So we have our equation. Pretty straightforward. So this last one, I'm going to try and move quickly because I know it's a long video. We're going to start with an equation where we've got y equals 5x. And what we know from reading this equation is that we have a constant of proportionality of 5. In other words, whatever I choose to pick for my story, whatever my x is, I'm going to multiply it times 5 to get to my y, to get to my dependent variable. Well, let's start with a story because I always like that. We could say every day Josh drinks 5 bottles of water. So we'll put our days and we'll put our bottles of water. So we'll go by days, 1, 2, 3, 4 days. And we said we're going to multiply by 5 because that's our constant of proportionality. So after 1 day, Josh drinks 5 bottles. 2 days, 10 bottles. 3 days, 15 bottles. 4 days, 20 bottles. Then we're going to go over here to our graph and we're going to put our labels of days and bottles of water, and we're going to add our numbers along our graph so that we can graph it. And then now we're going to put these points in. Now remember, we said all proportional relationships start at 0, 0. It must start at 0, 0. We'll put these other points on our graph, 1, 5, 2, 10, 3, 15, and 4, 20. And then we're going to draw our line from that proportional 0, 0 all the way out into a straight line, and we show our proportional relationships. I know this was a long video, but I'm hopeful that you understand proportionality a little bit better and are able to do it on your own after watching this video. Thank you.